The last type of conic section we shall talk about is hyperbola with center at the origin. Hyperbola is a set of all points in a plane such that the difference of its distances from two fixed points is constant. The fixed points are called the foci of the hyperbola. A hyperbola, like the ellipse, has two axes of symmetry, two vertices, two foci, and two latus rectum. The intersection of the two axes of symmetry is the center of the hyperbola. The center is the midpoint between the two foci. The hyperbola intersects the focal axis in 2 points called the vertices. These vertices are the endpoints of a segment. This segment is called the transverse axis. It is a line segment joining the two vertices. In ellipse, we call that the major axis. Pero sa hyperbola, ang tawag na dito ay transverse axis. Also take note that the center is also the midpoint between the two vertices. Another axis that plays an important role in defining the hyperbola is the conjugate axis. It is perpendicular to the transverse axis at the center. This axis has no point in common with the hyperbola. Take note that to determine the vertices, we solve for A, and to determine the endpoints of conjugate axis, we solve for B. The axis that contains the foci, the center, and the vertices of the hyperbola is referred to as the focal axis or principal axis. A segment passing through a focus that is perpendicular to the focal axis is called the latus rectum. A pair of lines that is closely related to, but also not part of the hyperbola are the asymptotes. The asymptotes intersect at the center of the hyperbola. A hyperbola approaches its asymptotes but will never intersect them. An auxiliary rectangle that is also not part of the hyperbola plays an important role in graphing the hyperbola. A pair of opposite sides of the rectangle passes through the vertices. The other pair passes through the endpoints of the conjugate axis. And as you can observe, each of the asymptotes passes through the opposite vertices of the auxiliary rectangle. There are two cases of hyperbola: a hyperbola with principal axis on the x-axis and hyperbola with principal axis on the y-axis. If the focal axis or principal axis is the x-axis, the foci and the vertices are on that axis. And this is the graph of the hyperbola with principal axis on the x-axis. The graph consists of two disconnected curves called branches. And these are the directrices. On the other hand, if the principal axis is the y-axis, the foci and the vertices are also on the y-axis. And this one is the graph of hyperbola with focal axis on the y-axis, while these are the directrices. Let us discuss the characteristics of the graph of these hyperbolas with center at the origin. The equation of the hyperbola with principal axis on the x-axis is x squared over a squared minus y squared over b squared equals 1, where c is equal to the square root of a squared plus b squared, and c is greater than a. While the equation of the hyperbola with principal axis on the y-axis is y squared over a squared minus x squared over b squared equals 1. This is the graph of this equation, x squared over a squared minus y squared over b squared equals 1, while this one is the graph of the equation y squared over a squared minus x squared over b squared equals 1. As you can observe, sa equation ng hyperbola, malalaman natin kung nasa x or y axis siya kung nauuna ang x squared or y squared. Unlike sa ellipse, kung saan denominator ang tinitingnan natin para malaman kung nasa x or y axis ang principal axis. If the denominator of x squared term is greater than the denominator of the y squared term, then the principal axis is the x-axis, and vice versa. Pero pagdating kay hyperbola, hindi na ang denominator ang ating basihan para masabi kung ang principal axis ay nasa x or y axis. Kung x squared ang nauuna dito sa equation, then the principal axis is the x-axis. At kung y squared, the principal axis is the y-axis. Dito sa hyperbola, we cannot conclude that A is greater than B as in the case of the ellipse. Hence, A may be greater than, less than, or equal to B. So dito sa hyperbola, pwedeng mas greater ang value ng A kaysa B. Pwede rin less than B, or pwede parehas ang value nila. Here, C is now greater than A. And the formula in finding the value of C is now the square root of A squared plus B squared. Sa ellipse, the formula is C equals the square root of A squared minus B squared. Sa hyperbola ay A squared plus B squared. Dito sa ellipse, mas greater ang value ng A kaysa B at C. Pero sa hyperbola, mas greater na ang value ng C kaysa A at B. Take note also that the operation is subtraction pag hyperbola at addition naman pag ellipse. Okay? The vertices are plus and minus A 0 if the principal axis is the x-axis, and 0 plus and minus A if the principal axis is the y-axis. The foci are plus and minus C 0 if it's on the x-axis, while 0 plus and minus C if the focal axis is the y-axis. Remember, kung nasa ng vertices, nandun ang foci. Kaya kung nauuna ang value ng A sa vertices, nauuna din ang C sa foci bago 0. Recall that transverse axis is a segment joining the vertices. Thus, its endpoints are plus and minus A 0 or 0 plus and minus A, which are the vertices, and the length is 2A. On the other hand, the endpoints of the conjugate axis are 0 plus and minus B if the principal axis is the x-axis, and plus and minus B 0 if the principal axis is the y-axis, and the length of conjugate axis is 2B. Kung nasa x-axis ang vertices at foci, nasa y-axis naman ang endpoints ng conjugate axis. At kung nasa y-axis naman ang vertices at foci, nasa x-axis naman ang endpoints ng conjugate axis. The directrices are x equals plus and minus A squared over C kung nasa x-axis at y equals plus and minus A squared over C if the axis is on the y-axis. Same ang equation ng directrices ng hyperbola at ellipse, plus and minus A squared over C. While the asymptotes are y equals plus and minus b over a times x if the principal axis is the x-axis, and y equals plus and minus a over b times x if the principal axis is the y-axis. So nag-switch lang ang kanilang value dito. They are both y because these are lines with a slope plus and minus b over a or plus and minus a over b. The length of the latus rectum of the hyperbola is 2b squared over a and the eccentricity is c over a. The same lang ang value dito mapa-ellipse or hyperbola. But the eccentricity of hyperbola is greater than 1 since c is greater than a. Sa ellipse, the eccentricity is between 0 and 1. So these are the characteristics of hyperbola with center at the origin. Let us have an examples. For the given hyperbola, find the center, principal axis, vertices, endpoints of conjugate axis, foci, asymptotes, eccentricity, and equation of directrices. Number 1, the equation is x squared over 16 minus y squared over 9 equals 1. Compare the given equation to the equation of hyperbola in standard position. The equation is of the form x squared over a squared minus y squared over b squared equals 1. Nauunang x squared sa equation. Thus, the center is at the origin, and the principal axis is the x-axis. So letter A, the center is at the origin. Letter B, the principal axis is the x-axis with the equation y equals 0. Now to determine the vertices, endpoints of conjugate axis, and foci, we need to find A, B, and C. So for hyperbola, a squared should always come first, but it isn't necessarily greater. This value may be greater than, less than, or equal to this value. So if a squared is 16, a is equal to 4, and if b squared is 9, b is equal to 3. To solve for c, we use the formula c is equal to the square root of a squared plus b squared, where a squared is equal to 16 and b squared 9. 16 plus 9 is 25, and square root of 25 is 5. Thus, c is equal to 5. And as you can see, the value of c is greater than a and b. So the vertices are plus and minus a, 0. The foci are plus and minus c, 0. And the endpoints of conjugate axis are 0, plus and minus b. Therefore, the vertices are plus and minus 4, 0, a is 4, then 0. And these are 4, 0, and negative 4, 0. On the other hand, the endpoints of conjugate axis are 0, plus and minus b, which is 3. So the endpoints of conjugate axis are 0, 3, and 0, negative 3. While the foci are plus and minus c, which is 5, 0. And these are 5, 0, and negative 5, 0. For the asymptotes, we use the equation y equals plus and minus b over a times x. Replace b with 3 and a with 4. So the asymptotes are y equals 3 over 4 times x, and y equals negative 3 over 4 times x. The eccentricity is c over a, or 5 over 4, which is equal to 1.25. And remember, the eccentricity of hyperbola is greater than 1. While the equations of directrices are x equals plus and minus a squared over c. A squared is equal to 16 and c is 5. The directrices are x equals 16 over 5 and x equals negative 16 over 5. These are equal to 3.2 and negative 3.2 in decimal.